We then, I then ask the class to list a sample space for 3 coins. Okay, if you're flipping 3 coins instead of 2. And if you weren't there, if you haven't done that, you should do that before you look at the result. But we got a pretty good set of lists. Most students had a pretty good looking set of lists. I walked around and looked at them. And I didn't look at them in complete detail, so I don't know if some people might have left one off or gotten one extra. But on the whole, the lists looked quite good. Some people chose to draw a tree. Well, it's easy enough to draw a tree for the 3 flips. You just take each result for 2 flips, like the tails, tails, and you put a heads, tails on it here. Tails, heads, you put a heads, tails on that, and so forth, and you get a nice list. I don't have room to list it up here, but you can see, and I think your book shows you that particular tree diagram in any case. Okay, now the way I listed it, I just used a different system. Okay, it came out with the same result that you would get from a tree diagram, and a tree diagram is a very good system. But anytime you try to list a sample space, you want to get a system. You want to use a system that ensures that you get all the possible outcomes and that you don't duplicate any. So my system here is basically list the heads as early as possible. So we start with heads, heads, heads. Then we go. We can't use 3 heads again, so we do heads, heads, tails. We put the tail on the end because that puts it as late as possible, keeping the heads toward the beginning. And another way of looking at this is we're just doing this alphabetically, heads before tails. Okay, then we do heads, tails, heads, heads, tails, tails. Then we go to the ones that start with tails. Tails, heads, heads, tails, heads, tails, 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 heads, tails, tails, tails. There's another way to look at that, and I'll probably throw that in here in a minute. But that would be a way of listing the sample space for 3 coins. Okay, extending what we see just a little bit. To get a sample space for 3 coins from the sample space for 2 coins, it's just another way of getting our sample space. We've seen that we can do a tree diagram, we can do an alphabetical listing. We take the sample space for 2 coins and we're going to generate the sample space for 3. And the way we do this is quite simple. I'm first going to list the sample space for 2 coins, and I'm going to leave myself a little room. We got heads, heads, we got heads, tails, we got tails, heads, we got tails, tails. I'm not going to put the end brace on this yet because I'm going to add something. I'm going to add a head in front of each of these. So I'm going to put a head here, and a head here, and a head here, and a head here. Now, that gives me 4 members of the sample space. None of these can be the same because none of these are the same. So that the last 2 in any of this, the last 2 heads or tails in each of the 3, each of the 3 coin outcomes that I've listed here are all different. You've got heads, 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 tails, tails, heads, tails, tails, all different. So no matter what I put in front of these, all 4 of these are going to be different. Okay, well, I put head in front of all of these, and now I'm going to do the same thing. But I'm going to put a tail in front of each. And I'm going to be able to end the set there. Again, the same reasoning tells me that all 4 of these are different because the last 2 in each one are different from the last 2 in any of the others out of these 4. And these 4 are all different from these because they all start with tails. So there's a new set. And if a head is equally likely to a tail, then each of these is going to be equally likely with each of these. We're going to have 8 of them, equal likelihood. Probability of any one is going to be 1/8. You see that each time we add a coin, we can do this. Okay, we can take our sample space for 3 and build a sample space for 4. We just list all 8 of these possibilities and put a head in front of each. And then we list them again and put a tail in front, and that's going to give us a new sample space, a sample space for 4 coins. Now I'm going to do that, but I'm going to do it off camera because you don't want to watch me write it all. Okay, here I've listed all 8 of the possibilities for 3 coins, from here to here, from heads, heads, heads to tails, tails, tails. Then I've listed it again. Now all I have to do to get a sample space for 4 coins is put heads in front of the first set and tails in front of the second. So I'm going to put heads here, heads, 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 and then tails. And you can see that I get a complete listing for 4 coins. Now just for comparison, again off camera, I'm going to write down the tree diagram for 4 coins and see that it corresponds exactly to what we see here. Okay, now before I step out of the way and reveal my tree diagram, I'll comment that it'd be a good idea for you to pause, write down the tree diagram, and see if you got it. Okay, well, here it is, not particularly well written, but it should be pretty self-explanatory. Off of every heads, okay, we got the first flip, heads or tails, and then we got the second flip, which can be heads or tails. Out of each listing of heads, we list again a heads and a tail. Off each listing of tails, we list a head and a tail, and we do that throughout for the third and the fourth level of the diagram. So what we end up with is, well, heads, 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 then heads, 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 tails, heads, heads, tails, heads, 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 tails, tails. And I'm not going to waste your time by listing all of these, but I'll list them off camera and see if the result agrees with what we got down here. Okay, here's the listing, and you can see that heads, 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 heads matches heads, 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 tails matches heads, 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 tails, and if we look at these in order, it's the same order in which they've been listed here. Now we can observe that the number of possibilities if you flip 1 coin is 2, heads or tails. If you flip 2 coins, it looks like there are 4 possibilities. If you flip 3, there are 8. If you flip 4, there are 16. What's the pattern of these numbers? 2, 4, 8, 16. Think about that before you hear me say it. Pause and think about it. Well, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. Is this pattern going to continue? Okay. Can you argue that every additional coin always doubles the number of possible outcomes? Now, that's what I'm going to leave to you to think about. I'm not going to tell you. But can you come up with a simple statement or a complicated statement, paragraph, book, whatever, that would argue that this is the case, that this pattern is going to continue? The next one will be 32, the next one will be 64, and no matter what, if you add a coin, you're going to double the number of possibilities, the number of outcomes in your sample space.